Hi learners, welcome to my YouTube channel. So today we are going to see the new topic, that is the integrals, part 1 of it. So the past year questions on this topic, the integrals. So here this is the question given over here. So that is d by dx of fx is equal to ax plus b and f of 0 is 0. Then we have to find out the value of this one, the f of x. So now first let us write the given thing, this over here. So what will we do here? We will integrate this. This is the left hand side and this is the right hand side. When we integrate this one, what do we get here? We get f of x and this will be integration ax plus b, and we write, whenever we write this, we write here dx. So now when we take out this into this one, this is going to be ax plus b. This one, that is going to be ax square divided by 2 plus bx plus c. So this is the f of x. So here now what are you going to do here? So here the a remains here. How did you get this one? X square. So you have to see that this coefficient means that will be x 1 plus 1 divided by this also will be 1 plus 1, that will be 2. So x is to 2 divided by 2 and a will remain the same, and this is going to be dx, and this we write whenever we write here c. So now we have here f of 0 is 0. So now in place of this x, you are going to write here 0. Now if we are putting the wherever you see x, you are going to put 0. So if you put here 0, a into 0 divided by 2, that is going to be 0. Again when we put here b into this 0, that is going to be 0, and this c remains here. So now what you can see, that is means you can see here c is 0. So now what are you going to put here? This c you will put in this equation. So how will you write the equation? Because they have asked what is f of x. So f of x means here in place of this c you are going to put 0 and this remains the same. So we have f of x is equal to ax square divided by 2 plus bx. Now this is the integral e raised to 5 log x dx is equal to, we have to find out. So now see here this is given. So now if we remove this one, this integration sign, so what is that going to be? This for this part. First we will not remove the integration sign. Let us see now only this part. So this part is going to be, this 5 will go in the exponent. So this is a raised to. So now what will you get? This is the rule for that. Whenever you have e raised to log of x is to 5, that is going to be x is to 5. So now we will see here. So for this one, we wrote over here, this is nothing but what did we get here? This integration over here. And for this part, what did we get over here? That we got x is to 5. So we'll write here x is to 5 dx. Now what are we going to do? Now let us look for this one. So now we are going to integrate this one, both this one. So integrating this one, when we integrate this one, so what will you get here? X is to 6 divided by 6 plus c. So how did you get this x is to 6? We have the formula, that is integration of x is to n dx. That will be, we have to add 1 to it, and again that will be n plus 1. So now here n is 5 plus 1, and here will be 5 plus 1, that is going to be 6 divided by 6 plus c. So this is the answer for this one. So now let us see they said here find integration of 2x divided by cube root of x square plus 1 dx. So now the numerator 2x will be same, but if we remove this square root sign, so what happens here? X square plus 1, this becomes 1/3. So now let us consider this x square plus 1 as t. So it can be anything. This can be in place of t. You can use any other variable. So here I put here t. So now what are you going to do? This is going to be what? 2x dx will be, first thing what will you do? You will take the derivative of this one. So x square plus 1 is t. So let us take here x square means the derivative of this will be 2x. 2x dx is equal to dt. Then later on we will put here in this integration, we will put here So here, see here 2x dx. So 2x dx. So what is that? 2x dx is dt. So this is dt. And here what did we consider this as? Here we considered this as t. And this is 1 by 3. So now what will we do? We will take this t raised to 1 by 3. If we take in the numerator, that is going to be minus 1 by 3 and this dt as it is. So now again what will we do? We want to remove the this one. So here the integration of t raised to 1 by 3 dt. So that will be what? Again we'll use the same formula what we did in the previous problem. So that is n plus 1 divided by x raised to n plus 1 divided by n plus 1 plus c. So what is here? This n is, you have to add 1 to it. Again we will add 1 to it here. So now what we get here? Minus 1 by 3 plus 1. We'll take the LCM of this one. So the LCM is 3. So that will be minus 1 plus 3 by 3. That will be 2 by 3. So this, the negative sign is gone. That is 2 by 3 over here. And again in the denominator also you will get 2 by 3 plus c. So now what you can do, see here. This is in the fraction. So this will get flip over. So when it goes here, this is going to be 3 by 2. And rest all here, this is the same. So now what we will, now we have, it's not completed yet because we have t over here and we had assumed that t is x plus 2 in the start. So we are going to write in place of this t x plus 2 plus 1 2 raised to 2 divided by 3, that is plus c. So this is the final answer. See that you don't forget to write this one, what you have substituted, considered here, and you have to substitute over here. So this is an important step. Then we'll do that, write the antiderivative of 3 root of x plus 1 by root of x. So now look at here, this is same thing what I wrote here. So here we will take the integration of this one, of this. So we are just put an integration sign and the same thing over here. So now this root of x can be written as x raised to 1 by 2. So here we will make it separately. We'll consider this as 3x raised to 1 by 2 dx plus, for this one again what we can write here, we'll make an integration sign, means this is separate, this is separate. So 1 by, again root x is 1, x raised to 1 by 2. So that is in the denominator. So now look at here, this is the same, but now here this is in the denominator, so let us put in the numerator, so this will be negative. So now this is a constant one, so we'll take outside the integration sign, this one, and the other part will keep as it is over here, and this whole part as it is for this step. So now we will use the rule. So what is the rule for this one? Whenever the integration is there, this is n. So what do you write here? X raised to n plus 1 divided by n plus 1. So when you put here, we'll put here plus 1 in this one. And so the integration sign is gone. And 1 by 2 plus 1. Again for this one, we'll do the same thing. Minus 1 by 2 plus 1 and minus 1 by 2 plus 1. And of course, you don't forget to write this plus c. So now what will be there? 1 by 2 plus 1. So that means the LCM is 2. So 1 plus 2 by 2, that will be 3 by 2. So this all will be same. And here for this one, you will write 3 by 2. Same for here also 3 by 2. And here minus 1 by 2 plus 1. So here it will be, the LCM is 2. So minus 1 plus 2 by 2, that will be 1 by 2. So this is a positive 1 by 2. So this also will be 1 by 2 plus. Now see here, this here, again here, this is going to get flip over. So here this is going to be 2 by 3. So this 3 is as it is. This becomes 2 by 3 and this as it is in the numerator. So now this becomes again what this will be flip over, means this 1 by 2 will be 2. So this is 2 and this as it is plus c. So now here we can cut this 3 and 3. So what remains over here is 2x 3 by 2 plus 2x 1 by 2 plus c. So now look at here, for this one, x raised to 3 by 2, we can also write that as x into x raised to this one, root of x. So how is that? Why is this root of x? Because x and root of x is x raised to 1 by 2. Root of x is x raised to 1 by 2. So whenever we write x, x into x is to 1 by 2. So whenever we write x, this is actually 1. So what in exponents we have seen that when the base is same, this should be added whenever there is multiplication. So 1 plus 1 by 2, that is going to be 3 by 2. So for this one, x is to 1 by 2, we can just write here root of x. Hope you got this one. This will be, so x into root of x. And here we have 2x half. So that is going to be, for this one, that is going to be root of x. So hope you got this. Why did we write here root of x? Because here we were getting root of x. So now what we can do over here, that we'll take the common. So 2 root of x here as well as here we have. So what will you do? That thing we are going to write it only once. And what remains in the bracket? See, 2 root of x is gone. So x remaining over here. Here nothing remaining means plus 1. So see, when you expand this, you get the same as this one, plus c. So this is the final answer. Now here we have to find out the antiderivative of 10x minus 1 divided by 10x plus 1 with the respect to x. So antiderivative is nothing but the integral, this one. So here now this is the same what we are writing here. So now we will take the integration of that one, same, but here dx. So this can be rearranged because we have the formula 1 minus 10x plus divided by 1 plus 10x. So when we rearrange, so if we bring this 1 on this side, there is minus over here. And here, so what will we do? Minus will take outside here and we write the integration sign. So here will be minus 1. And actually 10x means it's plus. So this will be plus. Hope you got this when we rearrange this. And here we can write the same because here what happens here? Plus 1 means either you write 10x plus 1 or 1 plus 10x because both is positive, both is the same. So here no changes, but only in the numerator there will be changes because here is minus. So here dx. So now we have the formula for 1 minus x divided by 1 plus 10x. That will be 10 pi by 4 minus 10x because 1 is here pi by 4. Pi by 4 means, we consider this pi means that will be 180 by 4. So that will be 4 4s are 16 and 4 5s are, so 1045, that is 1. So minus this 10x and here will be 1 plus this 10x. Well, this we can also write this as 10 pi by 4 and 10x dx. So now what is this? This whole thing is nothing but this one, 10 pi by 4 minus x. So this minus sign remains as it is, that is dx. So this is also, we can write this as minus log of, this will be sec of pi by 4 minus x plus c. Now here integration of sec x divided by sec x minus tan x equals. So let us consider this as I. This is the same thing. Let us consider this I. So now what will we do? We will multiply and divide by sec x plus tan x. So this I is here, this sec x as it is. We are multiplying by sec x plus tan x. Again, this is as it is in the denominator. And we are multiplying by sec x plus tan x dx. So here what we do here? Now when we multiply, see here, this into this, this into this. So what is that going to be? This into this is going to be sec square x. And this plus, you will put here plus x, sec x tan x. And here, see here, this is sec x minus tan x and this is sec x minus plus tan x. So this is going to be a minus b and this is a plus b. Can you see both are, why we say a, this means both sec x sec and both are 10. So a minus b and a plus b, that is, we have the formula a minus b and a plus b, that is a square minus b square. So see here, this a is the, so this will be a square minus b square. And now this is same what we wrote, that we have expanded, we have written it on the numerator. So now you know that sec x minus sec square x minus tan square x, that is 1. So the numerator, we'll keep it as it is. So anything divided by 1 is going to be the same. So now we will write it separately. For this one, we can write integration sec square x dx. Again, we'll put a sign here. For this, we'll write a separate integration, that is sec x dx. So what will we know? The integration of sec square x dx, that is nothing but 10x. And for sec x, integration of sec x dx, that is sec x. And this we have to write, whenever we write here, we have to write plus c. So this is the answer. So by this, we have completed. Hi learners, welcome to my YouTube channel. So today we are going to do the part 2 of the topic integrals, the partial equations. So this is the first one. So we have to find the integration of tan cube x divided by cos cube x dx. So now let us consider this as I. This is the integration here, the same over here. So what we can do here, we can also write here this tan cube x, and this is 1 by cos cube x. So 1 by cos cube x means that is going to be sec cube x. So that will be dx. So now we can write this as, here let us take this from here, we can take tan square x, and from here sec square x. So what 1 tan x remains, that we will take it on here, this side here, and here this 1 whatever remains from here sec x we will take over here. So now from here what we can do for this one, tan square x, we can also write as sec square x minus 1. This all will be as it is. So now let us consider this sec x as t. So now, and here, so this will be tan x, this one sec x dx, that will be dt when we take the derivative of it. So now what will we write in place of this one? We have considered this as sec x as t, so this is sec square x, that will going to be t square minus 1, and this will be t square, and for this one we have considered this is as dt, so in place of this we will write dt. So now what we can do, we can expand this one, that will be t raised to 4 minus t square, and this is dt. So now when we take the integration of this, you know that is, this will be t raised to 4, that will be t raised to 5 by 5, that is only a raised to n plus 1 divided by n plus 1. So this is 4 plus 1, that is going to be 5 divided by 5, and same for this one, 2 plus 1 divided by 2 plus 1, that will be t cube by 3 and plus c. So now we'll put this for the, this is not done, we'll put the value of this t over here. So what we have considered, this sec square, the sec x as t, so this will be, you will write here, this is 1 by 5, so we'll put it on this one, 1 by 5, and here in place of this t5, t raised to 5, that will be, because this is t is sec x, so that should be sec, this will be 5, and this will be x, and this will be now 1 by 3, and this will be sec cube x plus this is c. So this is the answer for this one. So now we are going to evaluate this one. So now look at here, this is the question over here, the same thing is written over here, and this thing we can also write this as the cos 2x is, the formula is, that is 2 cos square x minus 1, and for this one what we can write this plus 2, so let us write this plus 2, but sin square x we can write here 1 minus cos square x, because you know the identity, that the first identity is sin square x plus cos square x is going to be 1. So here sin square x is going to be, here if we rearrange this one, if this goes on that side, that is only cos square x, so that is 1 minus cos square x, and this, the denominator the same. So this I have written the formula over here. So now what you can do, you will write this as it is, this as it is. So now you will expand this one, so that will be 2 minus 2 cos square x, so this is the one, and dx, and this the denominator as it is. So now what we can do, we can cancel out this plus and minus, because this is plus 2 cos square x and this is minus 2 cos square x, that is cancelled. So minus 1 plus 2, that is going to be 1, and in the denominator is the same. So now you know 1 by cos, that is 1 by cos square x, that will be sec square x. So, and the integration of sec square x is tan x plus c, so this is the final answer. Now here we have to find out, this is going the integration of sin square x minus cos square x divided by sin x cos x, and that is dx. So same thing is written over here. So now let us separate. Now what we can do over here, this and this, we'll put it in this one. This is integration of this one. The minus sign is here. Again now this and this, we'll put it here. Integration of this dx. So now what we can do here, because this is sin square and this is just sine, so we can cancel out 1 from here. So in the numerator we just get single sin x, and the denominator, now this is gone. So we'll just get cos x, that is dx. Now same over here, what we can see here, when we cancel 1 from here, so what do you get? In the denominator only 1 cos x remains, and this is sin x dx. So now you know sin x by cos x means that is going to be 10x. So let us keep this as it is now. And cos x by sin x is cot x. So now whenever you take this integration of this, so that you can write as log of sec x minus log of this is sin x plus c. So this is the final answer. Now let us see, evaluate. This is given cos of 2x minus cos of 2 alpha divided by cos x minus cos alpha dx. So this is written over here. Let me consider that as I. So now what we can do over here, we can write for this one, cos 2x is 2 cos square x minus 1. This minus sign as it is, and for this one, this is just in place of this x, there is alpha. So the formula remains the same, but we have to just change it to alpha. That is 2 cos square x, cos square alpha minus 1. So now the denominator is the same. So now again this the same minus, and you are just going to expand it. That will be minus 2 cos square alpha, and this minus minus becomes plus 1, and the denominator the same. So now what we can do, minus 1 and plus 1 gets cancelled. So from these two, what you can see that we can take 2 common. So what remains in the bracket is cos square x minus cos square alpha divided by cos x minus cos alpha dx. So now what we can do over here, these two, we can take outside this integration sign, and then remains is this remains. So now we can also write this one, this is nothing but in the form of a square minus b square. So you know whenever there is a square minus b square means it will be a minus b and a plus b. So what will we write over here? That will be cos x minus cos alpha, and the other place you will write here cos x plus cos alpha for this one, and the denominator is the same. So now again 2 will be same, but now what we can do, we can cancel out this one. So what remains over here, that is cos x plus cos alpha, that is this one. So now this 2 again it will be outside. So now let us separate this one. So this into this one, that is the separate integration over here, plus again this into this, we'll put integration sign over here, this one. So now 2, that is cos x dx, plus this cos alpha we can take, because this is alpha and this is x. So this cos alpha we can take outside the integration sign. So what remains inside is 1 dx. So now what we can see here, that is 2 integration of cos alpha, cos x is sin x, and this cos alpha is same here, but here we can just write here integration is 1 dx is x. So you can also write here cos alpha x or x cos alpha, both is the same, plus c. So this is the answer. Now we have to integrate the function cos x plus a divided by sin x plus b with respect, WRTS means with respect to x. So now this is the integration that we can write I is, we can just write this one. So put dx sign, and because we have to integrate, so we have to put the integration sign. So we have to put this integration and the dx sign. So now this will be, this is cos a plus b, that will be cos a plus b, and we can also write this as cos of x plus b plus a minus b, that is dx, and this is sin x plus b. So now here after this one what we can do, this is cos a plus b. So that is the formula, that is cos a into cos b minus sin a into sin b. So this is the for cos a plus b. So now the denominator is this, and this is dx. So now look at here, we can take this cos a minus b outside here, and in the integration what remains here, if we are taking this, considering this part, so here what remains is cos x plus b divided by sin x plus b dx. And again here what we can do, we can take this sin a minus b outside the integration sign over here. So what remains here is this and this one. So sin x plus b divided by sin x plus b dx. So now this is outside same. So here what we can do, cos by sin, that is going to be cot, that is x plus b dx. And here what we can write here, sin, this is a minus b, that is as it is, but then this and this gets cancelled, so only remains is dx. So now look at this. This is cos a minus b, and when we take the integration of cot x plus b, that will be log of sine x plus b minus sine a minus b, and integration of dx is x. That is 1 dx. That will be x. That is plus c. So the same thing we are going to write over here. That is cos a minus b log of sine a minus b minus, we can also write here, because this x we have taken here, we can write in the start, that is x sine a minus b plus c. So this is the answer. Hi learners, welcome to my YouTube channel. So today we are going to see the part 3 of the topic integrals and the past year questions of it. So now let us start with the first question over here. So we have to find, that is integration of x is to 4 log x dx. So here, you know, this will be u into v, the integration of u into v dx. So this is the formula. Let's go to this formula. So here, which we have to consider u and the v. So you know the rule. So from here, which should be u and which should be v. So you know the rule, that is the I line. That is inverse. This is logarithm. This will be algebraic. And this will be trigonometric. And this will be the exponent. So from this one, now you can see which comes first is logarithm and then the exponent. So now let us consider this as u and this as v. So now what will we do? In place of this u, you will write here, first we will consider this as u. So that will be log of x. Because integration v means this is going to be x raised to 4 dx minus this integration of d by dx of, now you know that u is log of x, and this dx integration of this v of what? That is x raised to 4 dx, and this is d of x. So now let us solve this one. So this log of x, let us keep it. When you take the integration of x raised to 4, you know that will be 4 plus 1 divided by 4 plus 1, that will be x raised to 5 divided by 5 minus, here when we take the integration, you know the integration of log of x, that will be 1 by x. Here again x raised to 5 divided by 5 and plus c. So now we will take this together. So it will be x raised to 5 log x divided by 5 minus. Now here you can see this is in the denominator. This is 5. So we can take this 1 by 5 outside. And then integration of, again what will we do here? Here we can do one thing. This is x and this also is x. So here we can cancel out. So here we will get x is to 4 dx and plus c. So now this will be as it is, minus 1 by 5 also as it is here. So when you take the integration of this one, that will be x is to 5 divided by 5 plus c. So look at here, this keep as it is. So now when you multiply this into this, that is going to be 25, and this will be x is to 5. So what will you write here? This as it is, and this x is to 5 divided by 25 plus c. So this is the answer. Now look at here. They said if this will be from 0 to a, 3x squared dx is equal to 8, then the value of, we want the value of a. So now let us write the same over here. So when we integrate this one, so what will you get? You will get here, this 3 will take here outside. When you integrate this one, you are going to get this is x is to 2, means 2 plus 1 divided by 2 plus 1. That will be x cubed divided by 3. And this is 0 to a, we'll write as it is, and this is given as a. So now what will we do here? This 3 and this 3 gets cancelled. So what remains is just this part. So that is given over here, that is a. So now what will you do? In place of this x, you will write here a first. So that will be a cube. Then what will you do? You will write here 0. You will take here 0, right? In place of, so that will be 0. So now that is, this 8 can be written as 2 into 2 into 2. That will be 2 cube. So now this a cube minus 0 means it is going to be a cube. And this is 2 raised to 3. So now what you can see here, the exponents are the same. If the exponents are same, the base also should be the same. So here we get a as 2. So that is what they have asked. What is the value of a? So this is the answer. Now here, when we are evaluating this one, so now let us consider this I as this. So now what will you do? You will write here the 3 raised to x divided by log of, because this is a here, so that is a rule. So this is a formula given whenever we have such type of a raised to x dx, that is a raised to x divided by log of a. So now what we can see here, this is here means this is this is a and this is raised to x. So now what will you do? You will write here a raised to x as it is, then log of a. Log of a means this a we have 3, so we'll write here 3. This 2 raised to 3, that will be as it is. So now when we have this, you will take here this 1 by 3, 1 by log 3. This is in the denominator, right? So you will take a 1 by log 3 outside. So now we are going to concentrate on this one. So what will you write here? In place of this x, you will write here. First you will take 3. So you will write here 3 raised to 3. Then what will you do here? You just concentrate on this part. So here what will you do now? You will write 3 as it is. In the place of x, you will write here 2. So 3 raised to 2. Again, this will be as it is. So 3 raised to 3 means it is going 3 into 3 into 3, that is 27, and 3 square is 9. So what will be here? This will be 18. So that will be 18 divided by log of 3. So this formula is important. Just concentrate on this formula. So now here, this is given, evaluate integration of 0 to 3, that is dx divided by 9 plus x. So now here what we can do, this 9 we can also write as 3 square plus x square, because we have the formula this here. Can you see here? This is x square plus a square here, that is 1 by 8 10 inverse x by 8. So now what will we do? We have 1 by a. So what is here? A is 3. So because here this is x square and this is a square. So we have a as 3. So that will be what we have? 10 inverse. We have to remember this formula. That is 10 inverse x by a. So a is 3. So you have to write here 3. And that is, you have to write here which tends from 0 to 3. So you will write here. So now this 1 by 3 as it is. 10 inverse here. So here you know now first you are going to take x as 3. That will be 3 by 3. And then you will take this 0. So that will be right 10 inverse 0. See first here 10 inverse, this you will take in place of this 3 by 3, and then again you will take 10 inverse, this will be 0, but this one 3 is going to be 0. So now what you do right here, this 1 by 3 as it is, 10 inverse, this 1 that will be 1, and this 10 inverse 0 is as it is. Now this will be again here. So now 10 inverse 1, that will be pi by 4, and this is going to be 0. So now what will you do here? Again you can also write, if you want one step, pi by 4 minus 0 means that is going to be pi by 4. So here it will be pi divided by 12. So this is the answer. So now here it is given here, integration this one, sec square x dx is equal to, we have to write this one. So now we have, when you have the formula for this one, that is sec square theta d theta, that is 10 theta. So now you will just consider this one. So this is what sec square x, this will be, here is x, in place of this theta this is x, so you will write here 10x. So here because this is this, in place of theta you are going to write x, so that is the only difference. So you need here 10 theta, so you will write here 10x, and this is minus pi by 4 here, and this is pi by 4. So now what will you do in place of this x? So you will put here pi by 4 first, and then in place of this one you will write this minus as it is here, and here in this here what will you write here? In place of this you will write here minus pi by 4. So now what will you do? This, you know, this was 10 pi by 4, that is 1, this minus is over here, and this 10 of minus pi by 4, can you see this formula? That is minus, hope this is clear to you, this is minus 10 theta. So here what we have, theta is pi by 4. So just remember this one. So now what we can do, this minus becomes plus. So here what we can do, 10 raised to pi minus pi by 8, this will be 1. So again you will write minus plus, so here you will get 1 plus 1, that is 2. So just remember the formulas well. So now here it is given here, evaluate, that is the modulus of 2x minus 1 dx, that is from, this is from 1 to 3. So now this you can also write this one. This is a question here. The same written over here. This also you can write here 2x minus x dx. So now you will take the separate this one of integrate this one, the derivative of this one will be what? Sorry, this the integration of this one is going to be what? This will be, this is 1, that will be 1 plus 1, that is going to be 2, divided by 1 plus 1, that is 2 raised to x, 1 plus 1. So that will be 2x square by 2, minus when you take by 1 dx, that will be x integration here. So here 1 is to 3, 1 to 3. So now this 2 and 2 gets cut, so this is going to be x square, and this x as it is, this 1 to 3, that is going to be as it is. So now in place of this x, you are going to put 3. So that is going to be 3 square. Now here again, so that will be 3 square minus this one. If you take here, that will be just 3. So in the first bracket, you will write here. First, you will take this one, this, and then you will take this and this. So then minus of this one. So now you will consider for 1. So this 1 square is going to be 1. And then we will here 1 minus 1. So now what will you do here? This will be 9 minus 3, and this 1 minus 1 is 0. So 9 minus 3, the answer is 6. So by this we have completed the part 4 of the topic. This is called the integrals. From this integrals we are going to do the past year questions over here. So this is the first question over here. So same we can rewrite here. So we can consider that I is the same here. So here, when we see this this modulus sign, we can also write this as, that is minus x minus 2, this in the bracket. So now let us write in place of this minus into x minus 2, rest all the same. So now what we can do, this minus, whatever we are taken, let us take outside the integration sign, and what remains inside this one will be x minus 2. And this is x minus 2. So what happens here? This and this gets cancelled, that is going to be 1. So even if you don't write here 1, that is okay, that is understood, that will be, just we can write dx. So your minus is outside same here, and what remains is the dx. So now you know your minus again here, and the integration of 1 means that will be x. And this is minus 1 to 1, so it is same. So now let us keep the minus sign as it is. In place of this x, we are going to put here 1. Minus here, and then this minus 1. So now what happens here, minus as it is, minus minus becomes plus. So 1 plus 1, that is going to be minus 2. This is the answer. So now the next one, we have to find integration of e raised to x, 1 minus sin x divided by 1 minus cos x dx. So again, let us consider this I as the same. So now what we can write, there is a formula for this 1 minus sin x, that will be 1 minus 2 sin x by 2 cos x by 2, and for 1 minus cos x, that is 2 sin square x by 2. So the rest all we are going to write the same. So now what we can see over here, that this one will make two groups, this divided by this, and then this divided by this one. So e raised to x, so what will be right here, 1 divided by sin square x minus 2 minus here this one, that is 2 sin x by 2 cos x by 2 divided by 2 sin x by 2, and then dx. So here what we can see now, here this will be, now let us consider this first. So here 1 by 2 will keep it outside, but then 1 divided by sin square x by 2, 1 by sin, that is going to be cosec. So here is square, so we will write here cosec square x by 2. Now look for this part. So we can cancel from this one, 2 and 2 we can cancel. So what we can do, one more thing is this sin x, and from here, because this is sin square x by 2, so this sin square x get cancelled, and we get in the denominator just sin x by 2, and this cos x by 2 is as it is. So now that is dx. So now what we can do here, this all again we are going to write same, but now cos by sin is cot. So this is x by 2, so we will write here cot x by 2 dx. So now what we can do, this thing we'll bring it at the start, and this we will take it here. So now we have here fx is minus cot x by 2, and f dash x is equal to half cosec square x by 2. So we have the formula here first. The integration of ex, fx plus f dash x dx is e raised to x fx plus c. So we will just put the in this one. So what we can put here, that is we have ex f of x. So here we'll put here this one over here. This will write same. So this whole part we are going to write over here, and then what we know that this is this one part, is it? And we have e raised to x f of x. So here what is f of x? This minus we will take outside here, and e raised to x, that is cos x by 2 plus c, this part, because we have here minus cos x by 2. So this minus will be taken outside, and then e raised to x is here, and fx is cos x by 2 plus c. So now we have to find out this one integration x plus 1 divided by x plus 2 into x plus 3 dx. So here now let us consider, you can also write here as I. This I is we'll repeat this same over here. So now what we can see here, this we can also write the plus 1 as plus 2 and minus 1 dx, and this is the denominator the same. So now what will we do here? We are this is we have for this one, again we have the formula, this one, that will be, we can write here 1 by x by 3 dx minus integration of 1 by 2 minus 1 by x plus 3 dx. We can also write in this form. So now you know, now this will be 1 by x plus 3, that will be anything with this one, that is going to be log of x plus 3. We put here this one, log of x plus 3. And now for this one, what we are going to write, this minus sign is here, log of x plus 2. 1 by x plus 2 means that is going to be log of x plus 2. And then what we can see here, minus and minus becomes plus here. So 1 by x plus 3 means that will be, when the integration of 1 by x plus 3, that is going to be log of x plus 3 plus c. So now look at here, this we can also just write as, now we can see here, this is log of x plus 3. Here, this will be the modulus sign instead of the, yeah. So now what we can see here, this will be both when we add together, that is going to be 2 log of x plus 3, and this is minus log of x plus 2, this one. So this is the final answer plus c. Now let us find the value of, that is integration of 0 to 1, that is tan inverse x 1 minus 2x divided by 1 plus x minus x square dx. So now the same thing again here also, you can put a, you can consider this as I. The same thing we have written it over here. So now what we can do, we can rearrange this one like minus 2x. So we can also put here, we can put in a bracket this minus x, and the minus 1 more minus x will go outside. And again what we can do, this 1 will write as it is, and in this one we can put x common, and here will be 1 minus x. So now look at this one. So we can write this part as, now we are going to split this one like this. So we will write here, in one place we will write here tan inverse 1 minus x, and this minus sign is here, and this again what I said here, that will be tan inverse x, and that will be dx. So now here tan inverse, this one we can also, this one will now look at here, this will be, because we have the formula, that is whenever we write here f of x dx will be, this is 0, okay. And now 0 to a, that is f of x dx is 0 to a f of a minus x dx. So see here, this we have rearranged this one according to this formula. So now see here, so now what remains here is, so now we can see here, when we expand this one, 1 minus 1, that is going to be 0. and this will be plus x. So you can write here 1 minus x, that will be 1 minus 1 plus x. So this and this gets cancelled. So what remains is x. So that will be tan inverse x for this part. And here this is minus sign and this is tan inverse x. Hope you got this one. So you have to concentrate on this formula. According to that, you have to rearrange this one with the help of this one. So now see here both tan inverse x. So this we can, this is plus and this is minus. So this gets cancelled. So the answer here is 0. So we can write the original whatever this was. So this is equal to 0 because this has half mark. So don't forget to write this. Now here you have to find out integration of e. This is x raised to x square. This one into x raised to 5 plus 2x cube dx. So this we will consider this whole part as x, that I. Now here, what we can do for this one, that we can write, we can take this one the same, and from this one we can take x common. So what will remain in here? That will be x raised to 4 plus 2x square, and x let us take here, and that is dx. So now what we can do, this write as it is. So here this x raised to 4 we can write here x square. So this one is there. This will be same, and all this is the same. So now what we can do, we can see here x square. So x square, okay. So now let us consider this x square as t. So let x square is equal to 2. So when we take the derivative of it, that will be x square will be 2x dx, and this will be the derivative will be dt. So now this x dx, let us keep on one side, and when we take 2 on the other side, that is going to be 1 by 2 and this dt. So now what we have here, this I will be, see here, this I is going to be, we have this formula, e raised to x fx plus f dash x dx is equal to e raised to x f of x plus c. So now we have here half dt. So now what is here, what we can consider here, e raised to t. So how we can write this one as e raised to t, and this, for this one we can write as t square because x square is t, and here we can write here 2t because x square is t, and this is x dx is that is dt, but this half we have written it over here. Hope you got this. And then we have put the integration sign. So, and then now see here what we can do here. For this one we have this formula over here. So what we can do here, we can take here this half, and this what we want f of x. So here what we have, f of x plus c. So we can write here half t square plus c, because this is f of x. So here we can also, now we will put the whatever we have arranged here, we will say here x, this t, what is here, this one will be, t is x square. So we will put here x square, and then t square. So t square will be, x square is t. So t square is going to be what? X raised to 4, and this will be c. So we will write here further. So now what we will write here, this is x raised to 4. We can just rearrange. X will write in the start. This will put here, and this is 2 divided by 2 plus c. So this is the final answer. So now here we have to evaluate, that is integration of x square divided by x square plus 4 into x square plus 9 dx. So now here the same thing we'll take this as I. So now here we can again see this is x square. So now let us take this x square as t. So this part, now first thing we'll just remove this one and we'll do it separately. So we'll write this part separately. So in place of this x square we are going to write t, and here we are going to write t. This 4 will be as it is, here we will write t, and this plus 9 is going to be as it is. So now let us see this part. So this part we can just separate it. So how we can write it? We can also write it as a raised to t plus 4 plus t raised to t plus 9. So now here same thing over here. So now when we take the LCM of this one, so LCM will be, because here is t plus 1, here is t plus 9. So here we need t plus 9 extra. So what will we do here? You know the LCM here. You can also put here t plus 9 and here also t plus 9. So here a into t plus 9, and here what you are going to put here extra t plus 4. And here also t plus 4. So now what? B into t plus 4. And the LCM is t plus 4 and t plus 9. So now in the case, can you see? The both place it's the same. So that means this whatever is up, this one, this part is written over here. So now what you can see here, that this is 9 and this is 4. So we can take now this as, first let us consider this t is equal to minus 9. So if we put here the this one t is equal to minus 9, so let us consider this one t, this one. So we'll get the value of t. So if we are taking t is equal to b into t plus 4, so we are going to put here t is equal to minus 9 over here. So that will be, wherever you see t, you are going to put the minus 9. So that is going to be, this will be as it is, this will be as it is, and minus 9 plus 4, that is going to be minus 5. And now minus 9, this is multiplication. So this is going to come over here. So that will be in the denominator, that is going to be minus 5 is that b as it is. So now you know minus minus, this is going to be plus, so that will be 9 by 5. So the value of b, that is going to be 9 by 5. So now what will we do? We will consider now, first thing we have considered this t plus 9. T plus 9 means t is going to be minus 9. So now let us consider t plus 4, that will be t is equal to minus 4. So now see here, put here t is equal to minus 4. So now when we put here t as minus 4, so now let us see what we get the value. So this whole part, so I'll just minimize this one, a into t is going to be a plus this one. We'll write it over here, then we are going to put the t value as minus 4. So here we'll put here minus 4, this will be as it is, here t is equal to minus 4 as it is. So minus 4 is equal to this one, a as it is, and minus 4 plus 9, that is going to be 5. So now this again is multiplication, so let us take this 5 on the other side. So that is going to get divided. So here the same, numerator with the same, this will go in the denominator, that is a. So we got the value of a as minus 4 by 5 and b 9 by 5. So now let us put here. So now let us go to the main one. So what do we consider here as this part? So now see here that we have written over here, and we got the value of this one. So we had this, right? So this will be a into t plus 4 plus b divided by a divided by t plus 4 plus b divided by t plus 9. So now see here, in place of a, we are going to put minus 4 by 5, and that is x square plus 4, and 9 divided by 5, that is will be x square plus 9. So because why did we directly put over here? Because we had considered this t as x square. So we directly wrote over here x square. Hope you got this. You can just scroll and see. So now, this part, see here, we will just take minus 4 by 5 outside the integration sign, integration of, we can put here will be dx. Here, dx divided by x plus 4 plus this 9 by 5 outside the integral, that will be dx divided by x square plus 9. So now, look at here. So we have this minus 4 by 5. First, concentrate on this formula. Now, how is this one? See here, can you see? These both are the, this is in the form of this one, x square plus a square. So now we will consider this formula, that is integration of 1 divided by x square plus a square dx is equal to 1 by a. See here, 1 by a, tan inverse x by a plus c. So now this minus 4 by 5 will be as it is. So what is a over here? A is here. This will be this will be x square plus a square. So a square is 4. So a square is 4 means a should be 2. A square is 4, so a should be 2. So we will take 1 by 2 because we want 1 by a. Then this tan inverse. Then x let us keep as it is. And again, what did we see here? A, that will be 2. And now this is done for this part. Now let us see for this part. So that will be plus 9 by 5 as it is. Now what you can see over here, this x square plus a square. A square is 9. A square is 9. So a should be 3. So what are we going to write here? 1 by a. 1 by a means it is going to be 1 by 3. this tan inverse x divided by this one, we want a, that is 3 plus c. Hope you got this. This formula is very important. And so now what we can do, 2 1s are 2 2s are, so that will be minus 2 by 5, tan inverse this x by 2, 3 1s are 3 3s are, so this is going to be 3 by 5, and this whole part as it is. So the next one, there's a evaluate integration of dx divided by x into x plus x is to 5 plus 3. So same thing, we have considered this as I. So now what we can do here, x is to 5, let us consider as t. So now what will we do when we take the derivative of this part, that will be 5 x is to 4 dx, then this t means that will be dt. So what will be dx? Dx will be dt, and this will go in the denominator, that is going to be 5 x is to 4. So we can also write this one as, now see here, now concentrate on this one and this one. So we can also write this one as integration of, first let us write here, this is 1, we can write this one, right? So 1 by x outside, and this one will be x is to 5 plus 3. X is to 5, we have considered this as t. So we'll write here t plus 3, and this is, for this one, we have dx extra. So what is dx? This is dt by x, 5x is to 4, that is here. Just see here how to plug in first. So if this is clear, then now let us see for this one. So now 1 into this will be dt, and then what are we going to write here? See here, this into this will be what? 5 x is to 5, because x is to 4, and this one, that is going to be x is to 5, and let us write this as it is. So now what are we going to do? This dt will write here. Now we know x is to 5, this 5 let it be here, and x is to 5 means we wrote here for t. So here for x is to 5, let us write t, and this whole part here. So now see, this is 5, so we can write a 1 by 5. Let us take outside the integration sign. So now with the help of the partial fraction, we can write this as 1 by 3 by t. 1 by 3 by t, and this will be 1 by 3 divided by this because here t remains, and here this will be t plus 3 dt by using partial fraction. So now again what we can do, this 1 by 5 let us keep outside, and from this 1 by 3 let us take outside of the integration. So I have put a square bracket over here. So 1 by 3, and this integration, what remains is 1 by 3 goes out, this 1 by 3 goes outside the integration, so here remains is 1 by t dt, 1 by 3, and this dt, and this minus. So again from this also goes outside the integration sign, so what remains here inside is 1. So 1 divided by t plus 3 dt. So now let us expand this one. So this is going to be what? 1 by 15, because see, 1 by 5 and 1 by 3. That will be, we are going to multiply the denominator also, so that is going to be 1 by 15, and this the same. Again what will you do? This into this. So this is again going to be 1 by 15, and this will be integration 1 by t plus 3 dt. So now you know integration of 1 by t will be log of t. So this 1 by 15 as it is, for this one log of t minus 1 by 15, and this will be log of, see, 1 by t plus 3, that will be log of t plus 3 plus c. Now let us put the original one we have considered for t as x is to 5 in the start. So let us put the value here, and other things are going to be the same. In place of this again t, we are going to put here x is to 5 plus 3 and plus c. So now we have the rule for this logarithm. We have this 1 by 15, let us keep here. For this one, we have whenever this log of this minus this again when it is, so what is that? That is going to get divided. So see here, 1 by 15 both is common. So for this part, log of x is to 5 and minus log of x is to 5 plus 3, that is going to get divided. So hope this is clear to you, this part. Plus, so by this one we have completed our today's work. Do like and subscribe to my channel so you will get the notification of the other parts. Thank you.
The request is to subscribe to the channel, which is free. By clicking the like and subscribe buttons, you can show support and motivate us to continue producing content.